Now, question 2, moving from question 1, it says the general term of a quadratic number pattern is this one. So it is general, okay? And its first term is 8. Okay, so we know the first term of the quadratic. The general term of the first difference is this one. Remember, okay, I'm going to come to this. Remember when you're looking at a quadratic formula or quadratic number pattern, what's special about it is the second constant difference. So when you first find the differences, the first difference will form you an arithmetic or rather a linear equation, okay? And then the second one will now be the constant one. So let's see. They told us the first term, it is 8. The second term, I'm going to say it is x, y, z, blah, 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 blah. And then, will I know, remember I know that whatever that is here, I have the general formula for it, which is Tn is equal to, actually Tk, it is equal to 4k minus 2. So I can find the first term of the first difference by substituting T1, it is equal to 4 into 1 minus 2, blah, 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 like that. So if you were to do that continuously, the first one is going to be 2 here. If you substitute 2, it's going to be 8 minus 2, which is 6. And then 3, it's going to be 10. And then blah, 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 blah. Up to there. Up to wherever, guys. Okay. And then now let's confirm if my second constant difference is the same now. Yes. Is it the same? Yes. So 6, remember it's this minus that. 6 minus 2 is 4. 10 minus that, it is 4k sharp. Remember, they did not ask us for that. What did they ask us for? They said now, what is the what? What is the second? And let me say T2, T3. What is determine the next two terms? So how do we find the next two terms? If this is found by saying T2 minus T1, therefore it means I can say this plus that should give me that. Okay, so T1 is going to be 8 plus 2, which is 10. And then, sorry, T2. And then T3 is going to be 10 plus 6. I guess this one, you say this plus that, it gives that. So it's going to be 10 plus 6 is going to be 16. So, yeah, just like that, guys. And then let's see what they ask from us now. Hence or otherwise. Okay, hence or otherwise, show that the general term of the blah, blah, blah is given by that. So we know that this one, it is 2a, it is equal to something. 3a plus b is equal to something. And then a plus b plus c is equal to something. So we first find this one, 2a is equal to 4. And then a is equal to 2. 3a plus b, it is equal to, 3a plus b is equal to what? 2. And then b is going to be 2 minus 3. And then I substitute what is a. A is 2. And then b is going to be just negative 4. And then a plus b plus c, it is equal to 8. The first term, it is 8. And then c is going to be 8 minus, what is a? 8 is 2 minus b. Minus, what is b? B is negative 4. So be careful with your algebra thereof. So I have 12, 10. So that's how, guys. So they said, show that it is given by that here. So you already have the equation. You were just required to solve for A, B, and C, guys. For you finding this one beautifully thereof, it is a mark. If I think there is a mark here for you doing the beautiful mathematics, because A, B, and C you already know. Then the last one, how this was fairly beautiful and straightforward. It says 2.3, which term of the quadratic number pattern, okay? Which term of the quadratic number pattern will be equal to 35th? So they want to know Tn. Remember last time it is Tn is equal to 3050. What is Tn? Tn, it is what? 2n squared minus 4n plus 10. It is equal to what? 3050. And then let's do our mathematics thereof. When you do our mathematics, it's going to be 2n squared minus 4n minus 3050 is going to be minus 3040. It is equal to 0. And then I can take out these 2 as a common factor. So it's going to be 1520. And then the factors thereof is going to be n is equal to minus 40. You can quadratize, use quadratic formula, guys. And I know that n is going to be equal to 40, or n is not equal to negative 38. Remember, it cannot be equal to 38. Therefore, I like to say, therefore, T40, it is equal to 3050. Okay. But it's, you don't need to, the mark is here, and then equating and factorizing, and then concluding with only one answer. N is equal to 40. Let's move on to question 3. We are still under number patterns. So yeah, I'm going to record just question 2 and question 3 in the same video, because we are still moving with the momentum of what? Of number patterns. Beautiful. Question 3.1 says, given the geometric sequence 9 divided by 2, 9, 18, as well as to the last term. Remember, this is the last term, Tn. This is the first term, T1, T2, T3, blah, 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 blah. They say to us, determine the value of R. Sorry. R is going to be 9 divided by 9 divided by 2. Okay. Or you can say 18 divided by 9. Whichever that you want to use, basically. It should be the same. Then 18 divided by 9, it's going to be 2. Let me show you. This is also the same. 9 divided by 9 divided by 2. So when you apply your mathematics, you know this is the same as 9 multiplied by 10 times. You swap 2 divided by 9. Cancel. You are left with 2. So R is just equal to 2 here. R is just equal to 2. And then 3.1.2. Does the sequence converge? Now, for a sequence to converge, we know that the value of R should be between these two. But now the question is R between these two? The answer is no. So does the sequence converge? The answer is no. And then how do I motivate my answer? Because R is not between -1 and 1. Or R is not in that interval. Okay? Okay. How many terms are there in the sequence? How many terms are there? Well, we know the last term, again. We know the last term. So we can say, okay, Tn is equal to AR to the power of n minus 1, because this is what? A geometric again. How many terms? We want to find the number of n, and we have the last term. So the last term we're given to be 2304, and then A is the first term. What was the first term? 9 divided by 2. Then R, it is 2 to the power of n minus 1. And then just become a mathematician there. How? So divide by 9 divided by 2. Basically, 9 is just like to multiply by the reciprocal, which is multiplying by 2 and then dividing by 9. Let's see. 2304 multiplied by 2 and then dividing that by 9, it gives me 512. To the power of n minus 1. Okay. And then 512, I know it can be expressed as 2 to the power of 9 and then to the power of n minus 1. And then n minus 1 should be equal to 9, and then n should be equal to 10. So there are 10 what? How many terms are there in the sequence? There are 10 terms basically in the sequence. So yeah. 3.1.4. Determine the sum of the first 10 terms. Okay. So the sum of the first 10 terms, okay, this is not difficult. Remember, Sn is equal to A R to the power of n minus 1 all divided by r minus 1. And then Sn, sum of 10 terms, remember. So it's going to be first term 9 divided by 2. And then r is going to be 2 to the power of n. Okay, n we know it is 10. And then minus 1 divided by 2 minus 1. Some people ask, is it wrong to use this formula that says a to the power of 1 minus rn, 1 minus r? Well, I normally say use this formula if r is less than 1. Yeah, if r is less than 1, this formula is perfect. Okay, the formula is perfect like that. So yeah, but either way, I don't think it will have an effect, that much effect. Okay, and then the sum of 10 terms is equal to how much? For you lose your calculator there of 460.3.5. So yeah, that's that. Let's move on to 3.2. 3.2 says if the first term of the arithmetic is 18 series, arithmetic series, okay? So the first term is 18. The common difference is 3, okay? The common difference is 3. And the last term, it is 99. Remember, last term, it is Tn. And since when we are dealing with arithmetic, we know Tn is the same as A n minus 1, okay? A plus n minus 1 d is equal to 99. Remember, this is Tn. Last term, it is always Tn, guys. So, 3 to 1, write down the next two terms of the series. Write down the next two terms of the series, the next two terms. Okay, I already know the pattern starts with 18. And then I know the difference between the first term and the last term, it is what? It is 3. So if this is 3, so 18 plus 3 is 21. And then 21 plus 24. So the next two terms is this one, 21 and 24. So I'm going to say T2, 21, and then T3, 24. Guys, beautiful. Calculate the sum of the series. Calculate the sum of the series. Now, I know for the sum of the series for arithmetic, it is Sn. Sn, it is equal to, well, if I have the last term, but still I need to find the number of terms. It's either use this one, n divided by 2a plus n minus 1 d, or I use this one, Sn is equal to, is it n divided by 2 and then a plus l? Yeah. So yeah, where l, it is your last term. Where l, it is your Tn, last term. So we need to find, we already know the A, we already know the D. So we need to find what the sum of the series. We need to know the series has how many terms. So we need to first find what the number of n. So how can we do that? We know the last term, remember? So we're going to say Tn is equal to, Tn, remember, it is the last term. What is our last term? 99. A is 18. N minus 1, the difference, it is 3. And then 99 minus 18, it is 81. 81 divided by 3. I'm taking this to the other side, it's going to be 81. And then 81 is equal to n minus 1. 3. I'm going to divide by 3 by 3. So it's basically 81 divided by 3. I think it's 27. Yes. So it's going to be 27. It is equal to n minus 1. And then n is equal to 28. And then now I can now use my summation formula. I come here and say sum of 28 terms is going to be 28 divided by 2. What is A? 8 is my first term. 18 plus n, number of terms 28 minus 1, the difference it is 3. And then you get a beautiful answer of such as what is this, such as 1638. Or someone might use this formula and say S28, it is equal to n divided by 2, and A, it is just 18 plus 99, and then 1638. How do I know these formulas are the same? Just punch this on your calculator and you'll see how much it gives you. Or actually, basically this, remember this is 2 times 18. This is the same as 18 plus 18. So just take this and punch on your calculator. Say 18 plus into 28 minus 1, which is basically 27. 27 multiplied by 3. So it gives you what? 27. So you get 99. So yeah, that's that. Cool. And then let's move on to the last question. It says, if the even numbers are removed from the series, calculate the sum of the remaining terms in the series. So we need to know, okay, let's write down the pattern of our formula. Let's first find estimate. Okay, let's do this. The first term, it is 18, second term 21, 24, 27, 30, 33, 36, I think, blah, 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 up to the last term, I think is 99, up to 99, right? So they are saying if the even numbers are removed from the series. So if I remove the even numbers, remember the even numbers, how many letters? 1, 2, 3, 4. So 4 numbers. So it means they are divisible by 4, by 2. So it's those numbers. So which ones are those divisible by 2? So 18, yes. 24, yes. 30, yes. 36, yes, blah, 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 blah. So which ones are remaining? So the remaining are going to be 21, 27, 33, and then up to the last term, which is 99. So basically, I need to find the sum of this series. Is it going to be difficult? No. Okay, it's not. So we just need to say, okay, let's find the number of terms of this one. This is the odd pattern. Because we have removed all the even numbers. Okay, so Tn is going to be A, and then Tn is going to be what? 99. A is going to be what? A, remember guys, we're focusing on this one. A is going to be 27, not 27, 21, plus n minus 1. What is the difference from here to here? Blah, blah, blah. It is 6. Then when you solve for n, guys, you should see that your n should be given something like 14. Okay. And then when you get that 14, you now know the number of terms. So you're going to say S14 is going to be 14 divided by 2, 2A, 2. What is A? A, it is 21. Remember, okay, let me write down the formula that I'm using. N divided by 2, 2A plus n minus 1, the difference, like this. Or I can, since well for this pattern I know the last term, I can instantly go to this one, actually. I don't need to waste time. So it's going to be A, which is 21, plus N, which is 99. And then I have sum of 14 terms, which is something like 840. This is the method that you can do, okay? So, okay, there are people who might want to take the longer route. It's not necessarily long, but some people might say, okay, let us find the number pattern of the even ones. The number pattern of the even ones, which is 18, 24, 30, blah, 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 blah. The last term, I don't know, it's going to be, let's check here. 99 minus 3, it is 96. And 96, it is also even. So it's going to be the last term for the even ones. So the last term is going to be 99. So 96. And then we can find the sum of those that are even, okay? The sum of those that are even, we need to find the Tn for them again. And the number of n, how many terms they are. So we're going to say n is equal to 96. Let me use this one. 96, it is equal to a, it is 18 plus n minus 1, the difference 18 to 26 to 30 is 6. And then you find n to be equal to something like 14 also. And then when you find S14 here for this one, it's going to be 14 divided by 2. Then the first term it is 18 plus 96. And then you're going to say, okay, the answer that you get here, this, remember, is for the odd. And it is the one that we want to invert. Because when we remove the even number, so we are basically saying find the number, the sum of the odd, okay, because we have removed the even. But in this case, let's say we calculate for the even. And then it's going to give us an answer that says 798. But are you aware that you calculated for the even? But when we want the sum for the one, the odd. So we need to say S total, it is equal to sum that of the odd plus sum of the even, not 7, sum of the even. And sum of the total we have already calculated to be, because there are 28 terms again, to be 1638. To be 1638. And then sum of the odd is what I'm looking for. And then plus 798. And then when I subtract the sum of the odd, will give me something like 638 minus 1638 minus 798 should give you something like 840. So can you see the answer is the same? But preferably just remove the or, the even, and then try to create a number pattern of the remainders. You need the first 3 terms, I guess, and then even if you don't know the last one, is fine. But you need to know it because you need to find the number of n. So yeah. So that's that for this question, guys. I think it was the last one. Yes, it was the last one for the number pattern, guys. This question was very nice. So far, I see people getting totals. So let's move on to question 4, which is functions, guys. Hopefully you're moving with me. Okay. Yebo. Absabuza.